Hi, my name is Jonathan, and welcome to providing site redundancy and high availability in the SD WAN solution. We're going to talk about two types of high availability and redundancy, routing protocol redundancy and VRRP for next hop redundancy. So we're going to talk about service-side redundancy from a routing protocol perspective. How do we provide redundancy using just OSPF and BGP? And how do we do it in a bridge site design? And then we'll talk about configuring VRRP. Okay? So when you have redundant vEdge routers and multiple layer 3 devices behind them, we can run OSPF or BGP to achieve failover redundancy. By using these and redistributing both protocols into OMP, we can use the routing protocol loop prevention mechanisms to handle our routing protocol redistribution. And we can influence the routing protocol metrics to load balance across multiple available paths through the SD-WAN fabric, or to prefer one vEdge as a next hop router over the other for certain destinations. Okay? Ideally, what we would see is each vEdge router would have the same connections on it, so both of them would be able to provide the same levels of reachability. And then we can multipath from here across both devices, because both of them would be providing the same reachability to each of the layer 3 devices inside. So in a bridge site design, all right, basically both of these, the vEdges are connected in the same layer 2 domain right here. All right, we can use VRRP for first hop redundancy. Okay. Basically what we do is we have a virtual IP address that we're advertising. That virtual IP address is used as our default gateway. And then we have a floating MAC address that each one of these vEdges is actually responding to. The whole purpose of this is to provide a redundant gateway. So even though we have 3 devices, 10.0.0.1, 10.0.0.2, and 10.0.0.3, the default gate for all the devices is to this virtual IP address here of 10.0.0.4. Whoever the active router is, which in this case 10.0.0.1, he's the one who's going to respond to 10.0.0.4. So when client 1 sends an ARP request for 10.0.0.4, he's going to get the MAC address back for this guy. Okay? And that's basically the way that most of the first hop redundancy protocols work. Okay? That way we don't have to go in here and change the default gateway for these devices every time a device dies, and then we have to point them at the other one. That's generally just not a feasible scenario for most devices. All right? And the whole purpose of this is that one of the devices would become the master, and then we'd have backup vEdge devices. Ideally, the way this would work, though, is that all of them have to have the same connections on each device. Otherwise, each router is not providing the same, is providing different reachability, in which case they really can't back up each other. Okay? And then if he fails, depending on his preference and priority, when he comes back up, he would take over that master role depending on how important he is. Okay? And once this guy goes down, these two will have an election to determine who's going to be the new master. Generally, that's going to be based on priority, IP address, etc. Okay? VRRP is configured as a feature template, just like any other feature that we're going to deploy in the system. So we go to configuration features, and then feature template. Then there'll be a box there. It'll be like something like that, and it says VRRP in it. Select it, and then we can create a new VRRP template. Okay? We'll click New. And once we click New, we'll configure a VRRP group ID. Okay? We can modify a priority value here. Set a value from 1 through 254. We can set up our timers as well. And then we can take WAN side connectivity into account for VRRP by tracking an interface. And then we configure a virtual IP address. Okay? And then click Add when finished. Here's the CLI configuration. We're going to do this under the interface itself. So we're already in VPN 0 here. No shutdown. And then we're going to do an IP, here's we're going to configure our IP address and our VRRP group, and then our virtual IP address. Okay? Group number is going to identify the virtual router, by the way. And we can modify that priority value, set its value from 1 through 254. We can do that in the CLI as well. 2 physical routers are going to configure to act as a single virtual router. So we can configure the same group number on interfaces on both of these routers. Within each VRRP group, the vEdge router with the higher priority value is going to be elected the master. By default, each virtual router IP address is the default master election priority of 100. So the router with the higher IP address is elected the master. So if you don't set this, everyone's 100. And then they get to go look at their IP addresses. It depends. I mean, if all of them are the same, it doesn't really matter who's master. If all of them have the same connectivity, whichever one's master is fine because they all provide the same level of service. If they're providing varying levels of service, we're definitely going to want the one that provides the most services to have the highest priority to make sure he stays the master depending on what situation we are in the network. Okay. The master is going to periodically send advertisement messages indicating that it's still operating. If the slave routers miss 3 consecutive advertisements, they assume the master is down and they'll go into a master election. By default, these messages are sent every second, but you can change that from 1 to 3,600 seconds by using the following command. Setting this to 3,600 seconds is, I don't know why that's an option. I really don't. Sorry. We can also configure it to track OMP, right? So let's say I'm a master and I have tracking OMP and I lose my OMP routes, right? So I'm a router and all my OMP routes go away. Well, I don't want to be the master anymore if I can't provide any services. So let's take ourselves out of the equation. All right. This way a new master will automatically be selected based on priority value. Because this runs on the LAN interface, if a vEdge router loses all its WAN control connections, the LAN interface still indicates that it's up, even though the router is functionally unable to participate. Remember, even though this device is perfectly fine, it's still sending out heartbeats saying everything's awesome. Now that we're tracking OMP, we lose our OMP routes, and now we decide to abandon our master role and let the election take effect. Okay? And it's really simple just to track OMP on the configuration to do that. I recommend doing this on every single one because there's no reason to be advertising a master role in VRRP if you can't provide master role services. And then what we'll do is we can also say we can also track a prefix list. So if we lose a specific route, we can also abandon our VRRP master role. That may also be a priority. So if we have a specific functionality this router is in charge of, let's say a specific route to a data center, if we lose that, we probably also want to reduce our priority as well. Okay. And then we'll be referencing a list name, which is a prefix list that's on that we'll have configured separately. Okay. By the way, and this is basically, we won't even wait for the OMP hold timer to expire. We'll just abandon it. All right. And here's a VRRP configuration example. Let's see. We have interfaces. So we're looking at VPN 1, which is an inside service VPN. Okay. This is vEdge 1 and this is vEdge 2. All right. Here's our VRP and our group number. Notice those that have to match, otherwise the two of them will not participate in VRRP together. Here's our virtual IP address. Remember, it's the same. Notice that these two are on the same layer 3 subnet. So they're on the same subnet, so they're able to talk directly to each other. We're both tracking this prefix list. Okay? And I don't see the prefix list in the config here. They didn't grab it. Anyway. And obviously, we are also running another VRP instance on another interface. So we've got two separate interfaces with two separate subnets. We're running both. And we're both both advertising and making sure that that list is running. The prefix list and the number here is locally significant only, so it doesn't matter that it doesn't match on both devices. Okay? And this is on redundant interfaces. Notice that these are both in VPN 1, and I know let me bring that guy back so you can see it. So both of these interfaces, even though they're separate, they are both functionally under VPN 1, and the same thing on the other side. Okay? So this is service-side redundancy. Okay? And again, we can do show commands the same exact way we did before. We go under monitor, real time, and then VRP information, and then we will check and see whether our group number is up, what our master downtimer is, and what our current state is. And that says in NIT we should be up. Okay? And we can actually do the same exact command from the command line, show VRP interfaces. It'll show us which VPN we're active for, what interfaces, what our group is, VPN ID, our virtual MAC address that we're responding to ARP requests for, right? And what our priority is, and what our state is, and whether OMP is up, and what our downtimer is. And you can, by the way, modify almost all of these individual things. Okay. We can also show it specifically for the VPN if we have multiple interfaces in there. So before here we're showing the interfaces, here we're showing the VPN, and there's the interface, and it's the same information. All right? So we can use OSPF or BGP for that fault detection and reconvergence on the service side, or we can use VRRP for first hop redundancy. If you have redundant vEdge devices inside, you're probably going to want to run VRRP, especially if they're the same layer 2 domain. If they're not, if they're in separate sides of the network, that's not really going to be possible because they can't do first hop redundancy if they're not in the same first hop area. And basically, it uses a common virtual IP address. If you're familiar with VRRP on a Cisco router, we've modified the configuration slightly, but it's the same exact standards-based system. Okay? And that's the extent of this section. Thank you for watching.